Hey guys, today we're going to pick up where we left off with our math review at the start of the year, and we're going to look at linear graphs. Turns out linear graphs are very useful, which is why AP likes them so very, very much. As you recall from our math review at the start of the year, if a plot is supposed to be straight, it's pretty easy to tell if it's not. This is why we tried to manipulate our jumpers data so that it would make a linear plot, because then we would have a pretty convincing idea that we had the right pattern for its for to describe it mathematically. On the other hand, if a plot is supposed to be curved, if we're expecting it to be curved and we get a curved plot, it's pretty hard to tell if it's the right curve because there's a lot of ways to make curved plots. So yeah, linear graphs, good things. Linear graphs are also very useful if we can define the axes so the slope has meaning. And this is the other reason that AP likes linear graphs. Now, we haven't gone here yet. We mostly just talked about linear graphs with the jumpers and trying to change a curved data set to manipulate it to make it straight. But if we can design a graph from the beginning so that the thing we want to know about is going to plot as a straight line, there's two things. One, we can get a good measurement of that straight line because straight lines are easy to measure the slope of. And second, if we are expecting to get a straight line and we don't get a straight line, then we know that something is wrong. Either we've made a problem in gathering our data or we've made some bad assumption where the data set actually does not plot as a line. Anyway, so designing and setting up graphs to make linear plots is a very useful skill, and it's something that College Board wants you to know how to do. Okay, College Board wants you to be able to design experiments so that when you gather and plot your data, the slope of your graph will be the variable that you're investigating. And it's really not that hard to do. This seems kind of weird when it's so many words, but it's really not that hard to do. So here's one good way to do it. There's more than one way, but this one works really good well for me. So first, you got to remember this, that the slope of a graph is defined as the rise over the run. So here it is, the rise over the run to find the plot of a linear graph. Second, you find an equation that includes whatever variable College Board is asking you about. So if they want to know about acceleration, you just think of all of the equations that you've got or look through the AP Gouge for all the equations that include acceleration. So here's a couple of v equals at and d equals 1/2 at squared. I guess in our version it's x equals 1/2 at squared. But I think you recognize this. We've been using it quite a bit. Okay, next, we rearrange our equation so the variable that we want is isolated. So the v equals at, we can transform into a equals v over t. It's the same equation, it's just rearranged somewhat. D equals 1/2 at squared, we can rearrange to a equals 2d over t squared. Same equation, we just have the acceleration symbol on a side all by itself. Then finally, we make a graph where the y-axis is the denominator. I'm sorry, the y-axis is the numerator and the x-axis is the denominator. It's been a long day, I'm very tired. And then when you do that, then the rise over the run is the slope, which is your variable. So the slope of your graph will be the variable you're interested in. So then if you can think of a good way, reliable way to measure the velocity of something for some period of time, then maybe you can make it so the slope will be the acceleration. Now, mathematically, this looks good. Practically speaking, this might be a tough order to design an experiment to gather this, but mathematically it's good. But here's another way. You can take 2d as your numerator. Here, I'm going to move my picture a little bit. There we go. 2d as the numerator, that's the rise, and t squared as the denominator, as the run. And again, the slope will be a, acceleration. That looks like a good place to be. All right, let's try another one here. Again, this is not so much going toward designing experiments to calculate acceleration. This is about the math of how we manipulate equations to set up workable graphs. Part of the weeding out process. Okay, let's try this one. Oh yeah, this is why College Board likes it. When you plot all of your data into a best fit line, you have used all of your data. You're not cherry picking 1 or 2 points, then ignoring the rest of the set. When you make that best fit line, you are using all of your data, which is wonderful. So try this one. We're going to introduce this equation a little later on. So this you may or may not recognize this as Newton's law of gravity, but let's start with that equation. And you want to find G. So you're going to want to construct a graph where G, big G, is the slope. All right. So I would like you to pause the video at this point, try to work this out on your own. And then if you're stuck, or better yet, if you persevere and you finally come up with an answer, right or wrong, then continue the video. So here we go. This is the answer. All right. So here's our original. I'm sorry. Here's how we rearrange our equation to solve for G. Is Fg times r squared over m1, m2. Then you make the rise, the numerator, Fg times r squared. The product of the masses, you make that the x-axis, and then the slope will represent G. And this is actually the way that they experimentally determine G. They get 2 known masses, weigh them as carefully as they can. They literally calculate, or not calculate, they literally measure the gravitational force between those 2 masses, and then multiply this by the distance between them. What they normally use is gigantic lead spheres, or one small lead sphere on a spring scale, and then they'll roll a gigantic Indiana Jones-sized lead ball underneath it and see how much that lead ball pulls down the little one that's hanging on the screen. That's how they can directly measure gravitational force. They know the distance between them, they know the masses, and then they can determine G from that. If they use different distances, different masses, then they can get a variety of data and plot G using that method. Here's one more for you. Use the same equation, but this time make m2 the slope, the mass of the second object, the slope. So this is the original equation. Again, I want you to pause it and figure out how to do this. I'm going to start it in 3, 2, 1. Here's the big reveal. This is how you rearrange it to put m2 on one side. And then you can put the numerator on the y-axis, the denominator on the x-axis, and the slope will be m2. That's all there is to it. We're going to use this skill in a lab pretty soon. So this is a very, very useful skill. Make sure you know how to do this. The AP exam will ask you to do this, and I'm going to ask you to do it too several times between now and your exam. So this is a useful skill that you're going to use again and again. All right. Good luck to you, and we will see you next time.